Welcome to Webinar Wednesday. We have a great presentation for you today featuring experts David Collins and Kevin Tong of Excellitas Technologies. We will also be joined by Ralph Felton, General Manager, and Matt Brinson, Sales Manager, both of Atlas Specialty Lighting. These experts will discuss the revolutionary technology and benefits of high-intensity, perfect white light output for medical illumination, including Cermax technology innovations past and future. Webinar Wednesday would like to thank our sponsor, Excellitas Technologies. Extensive capabilities for design and manufacturing, from components to systems, make Excellitas the ideal partner for medical OEMs with the most demanding requirements when quality, cost, and ability to scale are critical. Please visit excellitas.com for more information. A few announcements before we get started. Please join us for continuing education, networking, and vendor engagement opportunities at our HTM mixers over the next few months. We will be in Milwaukee on July 14th and 15th, and in Kansas City on September 9th and 10th. Please visit htmmixer.com for more details, registration, and our steps to a safe and clean meeting environment. While you're there, please make sure to sign up for our newsletter so you'll always have the most up-to-date information. Let's give one lucky attendee the opportunity to win a newly designed Webinar Wednesday t-shirt by answering the following question. In what city and state is the Excellitas U.S. headquarters? You can answer the question by visiting our sponsor's website. Please use the questions feature on the GoToWebinar dashboard to submit your answer. As always, today's webinar is eligible for one continuing education credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey. More details on this at the end of today's webinar. We will wrap up today's presentation with a live Q&A. You can submit your questions anytime during the webinar by using the questions feature on the GoToWebinar dashboard. As I mentioned earlier, our speakers today are David Collins, Kevin Tong, Ralph Felton, and Matt Brinson. David, you may begin whenever you are ready.
Thank you, Jennifer. Good morning. Welcome, everybody. Thank you for joining. My name is Dave Collins. I've been working in the lighting industry for over 25 years with xenon lighting devices between product management, R&D, roles like that. And the Cermax product line is something I'm very familiar with. It's near and dear to my heart. I'm going to be covering a couple of topics today, ranging from the history of the company, the design and manufacturing of the lamps, and the vast breadth of Cermax products we offer and some of their applications. So Cermax is the pioneer and leader in ceramic body technology for guided arc lamps. Our lamps can best be described as a short arc xenon lamp, a point source of sorts, with an integrated reflector that gathers the light. Typically, these light rays are then coupled into a fiber optic, but in some cases, it's used for direct illumination as well. And additionally, we're the innovators of a patented metal body lamp technology, which expands the capabilities of the Cermax brand. Supporting the Cermax lamp brand, Excellitas manufactures lamp modules, power supplies, complete fiber optic illuminator systems, and expands on the supports of the capability of turnkey supplier focused on the specific needs of the customer. Includes a large offering of Cermax lamps, including lamps outside of the typical operating parameters that you might see in a medical theater, from 150 watts all the way up to 1600 watts. So this is a brief overview of our history. Started in 1978 with the VIX 150F. It's a company called Varian, still in business, developed up in Santa Rosa. The guided arc lamp technology was developed there. was moved over to a company called ILC in 1982, and the Cermax lamp technology and brand was created, really the only one of its type in the world at that time. And a lot of medical platforms were based around that for illumination, endoscopy, surgical headlamps, etc. In 1994, challenged ourselves and began to build the high wattage product line. We really consider high wattage to be anything above about 800 watts, but we've gone all the way up in our history to 2 kilowatts and beyond. Right now, we still have commercial offerings up to 1600 watts. A decade later, we started to move to expand the product line, looking at what the customers really needed in the market, and we put together the metal body technology. It's called ultra quiet. That's what the VQ stands for, very quiet. The metal body device has certain advantages with regards to cooling and efficiency and precision that you couldn't get out of the ceramic body. In 2008, we acquired the Viconics brand. This was a different technology that's slightly has an interface in the back, as you can see, a screw that allows for increased cooling technology and coupling into a heat sink. And then in 2017, we entered the Cermax MX technology, which is based around allowing a higher amount of light into a more narrow aperture, so higher brightness for smaller fibers, we can say. And 2020 was a challenging year for the entire product line. Sorry, not the entire product line, the entire world when it comes to the pandemic and other challenges. But we had the added weight of a production line transfer during this. We moved our production from the facility in Fremont, where we had been for a number of years, to our state-of-the-art facility in Indonesia. Excellitas has long had a foothold in Indonesia, as we've been working there for at least 20 years. But this particular product line was new, and we moved everything over in the middle of a pandemic. That was a challenging and fun time, but a very successful and rewarding one as well. So the basic overview, what are Cermax lamps? They're discharge lamps. That means an electrical arc is formed between an anode and a cathode, and the resulting plasma that's formed at that point is the light source for the lamp. The xenon is the fill gas. Xenon, among the noble gases, is the lamp that most approximates sunlight and gets the most efficiency electrical input to output. The key part about a Cermax lamp is there's an internal reflector in there. So the plasma is directly coupled to that reflector. So there's no intermediate body. The plasma is directly in proximity to the reflector, and that gives a much better coupling efficiency. Xenon shows an ideal spectrum. There's a large number of companies out there that actually use Xenon for solar simulation, either to test out solar panels or to do materials test in science. And Xenon is the preferred method to simulate the sun because it has all of the complete spectrum and very closely matches that of sunlight over the visible range. Lamps are operated with a power supply. They're typically relatively low current, 20 amps or less, but there's a high voltage ignition pulse that starts the lamp. That's the way to initiate any plasma discharge. And the wattage levels, typically 300 to 400 is the most typical, but as we said, we go all the way down to 150 and up to 1500 watts. It depends on the application. The main benefit of the Cermax lamp is it has a very high intensity source, which can be coupled into a fiber optic. This source has a very close color image to that of the sun, which means that somebody using the light coming out of that fiber sees something very similar to what they would see if they were operating in very bright sunlight. It's easily installed, instant on, and the ceramic or metal body technology is extremely robust. So that allows the very few failures and allows it to be transported from place to place without having any sort of optical issues arise from it.
So hi, my name is Kevin Tong. Let me give you a little background on myself before we start into the anatomy. I've been working for Excellitas in the lighting industry for over 25 years. Most importantly, I've been spending lots of time working on Cermax products, and that's probably over the last 10 or 15, actually much longer than that. So I've got a lot of knowledge regarding Cermax products, Cermax applications, how the products are manufacturing. Hold on, a little bit technical difficulties here. All right, so the key component to any arc lamp begins with the electrodes. Cermax lamps operate with direct current or DC power, and therefore the individual electrodes are uniquely designed for the operating mode. The anode and cathode are aligned with the axis of the lamp. This is where the differences between Cermax and other arc lamps ends. A high-intensity arc created between the electrodes emits light, which is shaped by the integrated reflector. A mirror light coating is applied to this conical surface to tune the light to the wavelengths desired and maximize the collection of light. At the front of a lamp, a sapphire window is crucial to provide a path for the light to exit the lamp. The choice of sapphire is critical to the design due to the high strength and broad transmission characteristics, spectrally spanning the UV, visible, and IR regions. For medical use and most other applications where only visible light is required, window coatings are utilized to limit UV and IR transmission. The last key element is the use of some type of dielectric material to insulate the opposing lamp polarities. Cermax's name is partly derived from the use of high-grade alumina or technical ceramic as that insulator. Now, there are many different materials that could have been chosen to build Cermax lamps. However, the high internal pressure associated with our designs limits what actually can be used. During operation, our lamps need to withstand pressures of 30 to 40 atmospheres. For some perspective, the average vehicle tire pressure is about 30 to 35 psi. Pressure inside a running lamp is typically 15 to 20 times that pressure. That exceeds the pressure experienced at a depth of 1,000 feet underwater. So while Cermax lamps are fairly compact, they need to be robustly designed, and our heritage and vast knowledge continues to prove that we are the leaders in development and manufacturing of this class of lamps. So, as said earlier, Cermax lamps are filled with high-pressure xenon gas. When the lamp starts, the arc ionizes the xenon gas, and the resulting plasma emits light that nearly approximates natural sunlight. Unlike LEDs, which are typically narrow-band devices created with several peaks of light, the spectral output of a Cermax lamp in the visible region is broad and uniform. This results in a color temperature closely matching that of the sun and a high CRI that shows true color. Simply put, with Cermax, reds look red. This benefit, along with the high intensity of Cermax lamps, are the key reasons that surgeons prefer Cermax for their most demanding procedures. Now, once the lamp is created, we need to direct it out of the lamp. For this, Cermax lamps are offered with different reflector profiles based on the designer's preference and requirements. For most lamp wattages, lamps are available in two basic reflector shapes, elliptical or parabolic. Elliptical reflectors focus the light to a point. This eliminates the need for a focusing lens when guiding light through a fiber and typically results in a simpler light source optical assembly. A con to this characteristic is the minimal space available for any additional optical components. Parabolic reflectors are used to create parallel rays that exit the sapphire window. This allows near infinite space for incorporating additional optical components, such as filters to fine-tune for specific wavelengths. A possible negative to this type of beam shape is the need to include a focusing lens if the intended is to be used with fiber optics. Excellitas offers a broad way of designs and very specific products to meet your very specific needs. Now, Cermax's metal body lamps have taken over the market over the last 10 to 15 years. While Cermax metal body lamps continue to provide our customers with short arc xenon lamps with integrated reflectors, as when we first pioneered this concept, this newer technology transitioned from a reflector body made out of pressed ceramic to one made of high-grade copper. This allows for a few different things. A reflector surface that is precision-honed to better direct the light, higher lamp-to-lamp output consistency, and a reflector made of a high thermal conductivity material to extract heat from the lamp. Because of far superior heat extraction, system designers are able to develop systems with reduced fan requirements, ultimately resulting in a reduction in system fan noise. Excellitas patented this technology and has revolutionized the industry with its superior output and extended life.
Thanks, Kevin. 2020 marked the completion of our Cermax product transfer to an all-new state-of-the-art facility located in the country of Indonesia. It's a challenging year to do a transfer. And one of the things I'd really like to highlight is a key part of our technology and our heritage is that we perform all of the processes in-house. We have challenged ourselves to become experts in metallizing, reflector coating, the brazing operations, the TIG welding, nickel plating, aging, testing, the optical outputs, etc. And we've maintained ISO 9001, 1345, 14001, and 45001 in the new facility. We always could have taken the easier route and outsource some of these technologies. In particular, I know a lot of choices in the industry kind of move that direction, but it's always been a core tenet of ours that we need to be an expert in this technology to understand how all the lamps go together, how to make improvements to move into the future. And so we challenged ourselves to set up this new expertise, thousands of miles away, and we did it in a time period where traveling was relatively difficult. We accomplished that by starting about 2 years earlier, having individuals sit over in our Fremont facility and having our Fremont individuals train directly in the Indonesian facility, so that when travel became a difficulty in 2020, those 2 years of preparation beforehand really paid off. And the production line has started up and has been doing extremely well for about, I think it's about a year now going on. So that work really paid off, and our expertise and understanding all of these technologies from the bottom up at a very technical level has really borne fruit with the success of that transfer. There's many processes we need to maintain in order to define our products and assure our customers are receiving the quality that they expect. For example, we age everything 100%. All lamps are aged for at least 2 hours to season the lamp. This eliminates the opportunity for early failure. Many lamps are aged to 24 hours and some longer than that. The reason that we do aging in some cases is most optical lighting devices have what they call a hockey-shaped curve, where they degrade relatively rapidly early and then get into a very repeatable degradation rate later on in life. So for some customers, it's quite important that degradation rate is very minimal in their application. So we do the aging at our facility first, so that it's in the more stable part of the aging curve as it reaches them. For other people, that's not as important. Testing 100%. We test 100%. Every single lamp, because it's energized and operated and aged, we also have the ability to test against the ICD conditions for light output, particularly light output through various apertures, etc. And 100% inspection. The Cermax product line is a premium product line. We inspect it 100% for cosmetic defects, appearances, And some things which, some people might consider cosmetic, we don't consider cosmetic. They're part of our product. And when you have, tens of atmospheres inside your device, you don't take chances. So that's something that we've built into our product throughout the years, and we will continue to do there. So when possible, we've made efforts to incorporate automation, eliminate error, and streamline process. This is continuing in our Batam facility. Our Batam facility is one of our leading facilities within Excellitas at advancing automation, and we will continue to see those benefits as we move forward. And the new site has been certified and in the process of being certified to many of the key ISO standards as the Fremont facility was.
So Cermax is an innovator in the lighting industry, having developed many technological advancements that are still currently in use today. Nearly 40 years ago, the Cermax name was born, and it was the start of a legacy. Not too long after, Cermax high wattage lamps were introduced. Along the way, patents were issued to document those advancements. 1999 marked the introduction of the Cermax mini lamp. With this miniature design, we were able to place our 150-watt lamp into a tiny lamp module and take over the medical market for whitening and UV curing. Additionally, the product was successful in specialized medical endoscopy. Our metal bottle VQ technology was introduced in 2006. This groundbreaking metal body design was optimized to efficiently remove heat from the lamp. The result, ultra-quiet operation. In 2008, we released the ingenious threaded-based technology that Iconics products are known for. This upped the thermal management efficiency of our typical Gen 1 ceramic body designs. Then, to expand on our metal body technology, the MX lamp was introduced in 2017. This enabled increased light output through small fibers. Cermax and its hundreds of patents have led and revolutionized the industry for over 40 years. The most common ways to purchase a Cermax product is either as a lamp or as a lamp module. This is highly dependent on the system design, as many of our OEM customers have taken on the task of developing their own heatsink designs to cool the lamp. In instances where the complete lamp module is required, this rendering shows a typical assembly. In addition to the material shown, thermal compound is the key component required to properly cool Cermax lamps. Using Excellitas assembled lamp modules ensures the module assembly is performed properly and therefore lamp cooling is not compromised. If the assembly is not performed correctly, it could possibly result in premature lamp failure. Proper training and tools required for thermal compound application and module assembly. So as we venture outside the medical market, I'd like to introduce Ralph Felton and Matt Brinson from Atlas Specialty Lighting in Florida. We've been working with Atlas for decades, and they're one of our premier distributors for Cermax and Excellitas products. Ralph and Matt, take it over.
Thanks, Kevin. I think that I was invited on this because I'd be considered to be the grandfather. Been working with this product for 35 years now, and what a great product to work with. They have developed just a multitude of applications using the same principle, but through a multitude of designs. The video projection. And there's a lot of video projectors that are out there now and have been out in the past that use a version of the Cermax lamp. Beyond that, searchlights. One of the first things that Cermax was used in was in a searchlight on board a military vehicle. It was quite interesting, and they've been able to take this technology all the way up to as high as, I think, 3,000 watts at one particular point. But nevertheless, these lamps are fun to work with as far as I'm concerned. And you can imagine you're used to working with the smaller 150 or 300 watt, 400 watt sizes. But think about getting up into a kilowatt or a 1.6 kilowatt. A lot of different things that can be done with it. In today's market, we find where it's used in semiconductor manufacturing for surface annealing, exposure, uh, testing of semiconductors in a rapid manner with high intensity light. You know, just about everything that we're used to is subjected to testing for how it's going to hold up over time, how the climate's going to attack, whether it's plastics, whether it's metals, what have you. These can be used and are used in both a non-destructive and a destructive manner in testing to see the performance and how long these materials will last when subjected to either UV or visible or an inordinate amount of infrared light. In our experience, solar simulation, I mean, that's a wave of the future, and these solar cells have to be tested for their performance. Based on that, Cermax is premier in that marketplace, testing how your sunscreen's going to work. You know, we're down here in Florida, but some of the biggest testing facilities are in Daytona Beach, and they do it by visible light, infrared light, UV light to see how effective their product is. Then you can go on down into climatology as it relates to the movement of gases and how it affects the ozone layer, to calibration in metrology, you know, calibration of light. It has to be calibrated somehow, and there has to be a standard. And by standard, Cermax is used in setting the standards. Then a unique area is film. Film, as we know it today, is going away, but there is still a lot of archive that's out there in film, and it's being converted to a digital format, so you can play it on a DVD. Of course, that's headed out. You can tell my age. That's headed out the door, and everything's streaming now, but it's streamed in a digital format. So they take the film and they transfer it into a digital format for that purpose. And Matt's keeping me company here just to so that I don't go crazy on my inability to technologically keep up with this presentation off of the cell phone. But we do thank you.
Sorry, as we say in 2020 and now 2021, I was on mute. Matt, Ralph, thank you very much. Cermax Grandpa, that was a great line. I appreciated that. In addition to the Cermax lamps and modules, we also offer power supplies. It's important for us to provide a reliable method to power our lamps. Excellitas lamps will work with a variety of power supplies, but we have our own power supplies that we also offer to the OEM systems. Power supplies in general are operated in two modes, either constant power or constant current. As a lamp is used, the electrodes experience wear, which results in an increase in the operating voltage. In the constant power mode, as the voltage increases, the power supply automatically lowers the current to maintain the system power. Constant current mode, as the voltage increases, the lamp power consumption also increases. And this will increase the power, which also potentially slightly increases the output as the lamp lifetime ages. For additional information regarding a power supply for your system, please contact Excellitas or one of our distributors. A list of distributors can be found on the www.excellitas.com. And then we also offer our own fiber optic illuminator, the XL3000. This particular device was designed in-house, couples an Excellitas lamp with an Excellitas power supply. We have a history in light source design, helping out other OEMs, supporting them as they move through that process. In some case, doing some of the building and manufacturing of the devices, but we also offer our own as well. And so it's been the basis for multiple custom OEM systems and showcases our understanding of the Cermax lamps as complex interactions. Our expertise in this area means we're also sought off by OEMs to assist in their designs and execute on their builds. We provide basically a simple solution to system integration from the light source itself all the way up through the power supply and the rest of the integration. Additional information can be found in the Cermax Engineering Guide, and this is an invaluable resource. We use it internally when we have new engineers come on board. We take a look at this, and it's one of the Bibles, we might say, of Cermax lamp design and application. It's really aimed more towards users, but it's also very useful for us internally. If you'd like to request a copy, contact james.clements at excellitas.com. Jim Clements is another one of us who has spent a long amount of time in this industry and is very knowledgeable about this technology. So anything that you need, I'm sure Jim can help you with that. The guide is developed over many years, contains a wealth of information on Cermax lamps, their operations, their usage. So if you're interested, please reach out. It's digital, so we have plenty of copies printed. So, and then in addition, any other questions for detailed answers, more in depth? We can also please contact James or Jim Clements at james.clements@excellitas.com. And now it goes to the questions portion of the presentation.
Thank you all so much for all of this valuable information. As a reminder to our audience, if you do have a question for the presenters, please use the questions feature on your webinar dashboard. We do have a few questions that have come in already. The first is, what are the advantages of Cermax lamps over other lighting technologies?
Okay, so the advantage of Cermax lamps over other lighting technology, I think the two main ones are, number one, that the light source is very closely approximated that of sunlight. That means when you're looking at a working surface, you're seeing the same light that you would see from the sunlight, which is very good for the human eye. It makes it easier for surgeons or technicians to do the work that they're doing and understand what they're working on. The second one is the integrated reflector inside of the design. Very closely couples to fiber optics, or in the case of a parabolic light source, the collimated beam allows very bright light farther away from the light source. So those two things are the core technologies that we've built Cermax on.
All right, our next question is, what is the lifetime of a Cermax lamp?
I can take that one. So lifetime, it's actually very system dependent. It really depends on how the systems were designed and how they're actually using the light. In addition, it really depends on one of the key factors, which is cooling the lamp. If the lamp is cooled properly, it can last a pretty long time. We've had OEMs we've dealt with over the years who've used some of our lamps for 2,000 to 4,000 hours in their applications. So, like I said, I mean, I would say typically in the medical market we say anywhere from 500 to 1,000 hours, but it really depends on the system.
Our next question is, how can the operating environment contribute to variations in lamp lifetime?
I'll take this one. So the Cermax lamp, in general, as Kevin said, it gives a very reliable lifetime, but there's a couple of things that are very important to note about it. Number one, the device isn't an instant on and off device. It runs continuous. So always lifetime is going to be better if the lamp is turned on and allowed to operate continuously for minutes to hours at a time. So, for example, if the lamp was to be turned on, operated for 3 or 4 minutes for an operation, then turned off and turned back on again, that creates thermal wear on the electrodes that creates a nonlinear aging pattern. So it is important the device is turned on and operated near its optimum operating current for its lifetime. Another point is that the environment that the light source is in is very important. We need to make sure there's particularly good airflow through the device. This is a high wattage device that has no water cooling. It's all forced air. So dust that gets put into the system, fans that are obstructed, damage like that can also be. Kevin also pointed to something a little bit earlier. When Excellitas assembles the modules, we have a long history of making sure and understanding the correct interplay between the lamp itself and the heat sinks, applying plenty of thermal compound, ensuring the heat sinks are tight around the metal interfaces of the lamp itself. So if for some reason the lamp is not properly installed into the heat sinks that it's in, that can create a overheating of either the front or the rear part of the assembly, and it can also create more rapid aging patterns. So those are the things you generally like to avoid.
Our next question is, what is the proper method for depressurizing xenon lamps for disposal?
Yeah, I can handle that one. In one of the slides, we actually showed, I believe, what we called an exhaust tube or a fuel tube. So at the end of our pumping process, where we actually show the high pressure gas into the lamp, we swage that down. Now, so that's what's actually keeping the high pressure within the lamp. So typical method is if you can get it down to just the lamp by itself by removing the heat sinks, you get access to that tubulation. And the method that we use in-house is we usually, obviously, wear proper safety equipment, protect the eyes and all. But what we use is a pair of wire cutters, and we don't actually cut entirely through that tubulation. We'll cut maybe halfway through and twist the lamp, and that will cause the copper tube to basically shear off just enough to allow gas to escape, and you can hear it. And once that gas starts escaping, then that's it. It'll come down to regular pressure fairly immediately.
Our next question is, what is the most effective spectral power distribution for human vision?
I mean, for human vision, it's basically coupled into the light that comes out of the sun, right? And so the human eye's evolved in such a way that it's sees its peaks right around in the green part of the spectrum, and the solar spectrum is the center of the photopic curve, and I think that's also where the Cermax lamp is also at its brightest. When it approximates sunlight in sort of a NIST traceable standards, you know that it's going to be a good match for the human eye.
Our next question is there a standard for bulb/light source manufacturers on how to measure lux? And a follow-up is, how does color temperature affect view on surgical field?
So I'm not aware of any standard that's used to measure lux. There might be, that not actually sure. We'd have to get back to you on that. But the color temperature is a very important factor, because the color temperature it shows how close something is to sunlight and basically explains how good of an image the surgeon or the person working in the surgical field is going to get. So our lamps being very close to sunlight are, again, show a very, that's exactly why they are where they are, I would say. They're closer to sunlight such that the color temperature looks exactly like that you'd expect from the sun. The other thing I should probably mention is because this is a continuous light source, when we start talking about continuous light source, I mean that all the spectral bands are represented like a true black body, right? The plasma becomes a black body emitter, similar to what you'd expect from Wien's law. And as a result of that, you see all of the spectrum represented from, the UV, unless it's blocked through the IR in a continuous arrangement. So all of those wavelengths are there. So when we have a color temperature, it's a true color temperature measurement. It's not attempting to extrapolate from, say, 3 individual wavelengths as some like LED systems do. So you get all of the wavelengths of light in between there, and that gives you the same vision of a irradiated or illuminated surface as you would get from sunlight itself. Hope that answered that question.
Thank you. Our next question is, comparing Excellitas to original OEM bulbs, Excellitas quality is equal to or superior to the OEM, but are more cost effective. How do you keep costs down?
So, the correct answer is that most OEM bulbs in the world are Excellitas bulbs. We supply to, we work with the suppliers and the OEMs when they've designed the systems from the very beginning. And I believe every single system in the world, Excellitas is a qualified supplier for. That may not be 100% accurate. I may be missing one here or there, but the truth is that Excellitas bulbs are the OEM bulbs. So we make both of them. In some cases, our standard designs that we produce in high volume, we produce them in high volume, and we have, the specifications are particularly geared towards our manufacturing processes and procedures. But Excellitas bulbs are OEM bulbs, and we always aim to be cost effective. That's a very important part of our legacy and our technology. This is an approachable platform that's at the right cost point for medical applications.
All right. Our next question is, doesn't the closeness to the light from the sun become a risk for clinicians who work with these lights for a long time? And is there a limit to how long one should work with these, similar to X-ray?
No. So the damage that typically comes from the sun's light would be from the UV. And if you take a Cermax lamp directly and you just applied a normal Sapphire Window to it, you would have an appreciable amount of UV, similar as you do from the sun. But almost all of our lamps for medical applications and almost all of our lamps have a specific coating put on the window, which ensures that none of the UV light comes out. So what you do has a very high visible light flux, but one of the graphs that Kevin showed earlier shows that we artificially cut off the transmission in the UV, and it's just for that reason. It's just for safety. Also, you would generate a lot of ozone, etc. That said, this is extremely high brightness light source. Stray light or light that's on your hand or something isn't going to do damage, but if you were to put your hand extremely close to the light source, you could cause some damage. And certainly the eye should never be in a position to look right down the fiber or look right down the lamp axis. But I think in general, most systems are designed so that's not a problem. But there's no exposure limits. This is the same light that you get from sunlight, and you shouldn't even be getting a sunburn from it because the UV light is filtered out.
Okay, our next question is, what is the pressure of the xenon gas inside of the lamp?
So it really varies depending on the lamp type we're discussing here. The pressure can be anywhere from, I believe it's 15 to 20 times atmosphere. So hopefully that answers the question.
All right, our next question is, xenon is high in the IR spectrum. Is that why the Sapphire window?
Well, that's part of the reason. So we got to recall that originally this lamp was not specifically targeted for medical. It's targeted for a lot of different applications. So there are some applications where IR is important. In applications such as the medical, we do apply window coatings to the window, and this actually tailors the spectral output so that we reduce some of the UV output, as well as reducing much of the IR output. So medical application, the light is tailored just to try to get more of just the visible spectrum.
Yeah, and I also say Sapphire is chosen for other properties. Optically, it's very transparent across a wide variety of wavelengths. It doesn't degrade optically as light passes through it over time. Some other materials, such as quartz, although they're have similar properties in that you can see light shine through them, they're not equivalent in terms of durability, in terms of maintenance over time, and in terms of transmission across the reliable spectrum. So Sapphire is used for a number of reasons. It's a premium material, but it's necessary for the variety of applications that we're supporting.
All right, our next question is, we use Cermax bulbs for our Pentax processors with no issues. When I call Pentax with a processor problem, one of the first questions I get is, do you have Pentax bulb in the processor? Is there a difference, or why is this question asked?
So I assume by processor, this is some sort of a sort of endoscopy unit or something like that. Yeah. I actually don't have any idea. I know that a lot of different OEM manufacturers will specify the use of their own bulbs. Those are the bulbs that they've tested and tried through the systems. And if another company is offering a lamp like that fits in such a system, then they should also ensure that it works in that situation. I don't know exactly the system that you're talking about, though, or the exact nature of that inquiry. So I'd have to probably look at that a little bit offline to understand the exact nature of that request. Kevin, does anything else come to mind?
Well, the only thing I can think of is they want to know which bulb you're using inside the system, because if it's a bulb that was never tested within their systems or using the test method that they have in place, there's no verification from them that the bulb is equivalent to what they're actually offering. So sometimes there are manufacturers out there who will manufacture bulbs and say, hey, they fit in the socket, but that doesn't mean they've been tested to the same requirements that Pentax demands.
All right,
Yeah,
thank you. Kevin, I'm not certain if you are able to unpause your screen so that folks can see how to get in touch with you, but we're not able to see your contact information anymore. I believe it's just paused. But I do thank you all for your time today. David, Kevin, Ralph, and Matt, that was a great presentation. I would like to encourage everyone to visit our sponsor today to learn more about the products they provide to our industry. Please visit Excellitas.com. A quick reminder to our audience that you can obtain your continuing education certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your one continuing education credit from the ACI, and you will be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, You can reach us at webinar@mdpublishing.com. We will be back next week with another webinar. Please visit webinarwednesday.live for more details and complimentary registration. Thank you all and have a great day.